I don't have my note. Well, I kind of didn't even pay attention to my notes anyway. So, respiratory system. Now, the thing about our respiratory system that we're going to find, the respiratory system is going to have an actual huge effect on our cardiovascular and urinary. Okay? So, very close connection to those systems. But the respiratory system, we have what it does, gas exchange. That is the biggest function of the respiratory system. Voice production, yay. Olfaction, smell, wow. Regulation of pH. pH of what? The blood. Regulation of blood pressure, and then affecting blood and lymph flow. If we look at what's going to happen, ventilation, that is the term that is used for air going in and out of this system. Now, do you guys remember cellular respiration? Okay, we'll mention that, but don't get them, in with this system a lot. I mean, it comes into play. But when we talk about respiration, we're going to say for this system, we have external and internal respiration. External, between the air in the lungs and the blood. Air going into the lungs and then the blood. We have our transport. Transport in this system is strictly oxygen and carbon dioxide. Internal respiration, gas exchange between the blood and our tissues. The structure of this system is the reason that we can do what we do. Any idea what this is? This is getting down to the point of our alveoli down to an alveolus. Okay? What do you kind of notice about it? Branching little sacs, lots of blood vessels, lots of blood vessels. Okay? Now, if this is trying to show me, okay, my little sacs, my little grapes, okay, this, with all the red and the blue, is trying to show me the connection with blood. That's our point for gas exchange. Because, now just pass the thread. What is the blood carrying? Our oxygen, our carbon dioxide. In the respiratory system, these are the parts of the respiratory system. Nasal cavity to the lungs. Diaphragm. Have you ever thought about your diaphragm? Okay. The diaphragm, this great big huge muscle. All right? Do you happen to remember what nerve innervates it? Phrenic. Okay? The phrenic nerve. Why is that nerve so important?
Because if you cut it, then you automatically your lungs aren't going to function.
Because it's not doing what? It's not causing the contraction and relaxation of the diaphragm. Now, I want you to kind of think about this for a second. When we look at the lungs are located within a pleural cavity, which are in my thoracic cavity. This cavity has the bones, the ribs, and the muscles that would be in between each of those ribs. And now this huge muscle right here. The muscles between the ribs are like this. Do y'all remember studying those in part 1? Okay, they're actually like crossed over like this. Okay, because they have to do this number. The other part about this cavity, when you hear the term cavity, what do you think about? Something closed in, a space, all right? That means this space has pressure. Now, not only am I talking about a pressure that is within this cavity itself, but I'm talking about a pressure outside of this cavity. Atmospheric pressure. Is everybody with me? Okay? So, the movement of the air through this cavity is going to be dependent on pressures. Your textbook is going to get into great detail about some of these gas laws. All right? We don't have that kind of time. However, I want you to understand that there are pressures acting on this system. Pressures outside versus inside. And once again, everything wants to flow from the area of high to low. The movement of the gases between the air in that alveolus and those capillaries that are attaching to it are going to be dependent on those pressures. Anybody going into respiratory therapy? You're going to get into this a lot. They're going to be expecting you to know Boyle's Law, Dalton's Law. They're going to be expecting you to know all of these gas laws. Okay? Now, in the structure that we have, okay, the nasal cavity from the nares to the choanae, they were invented that day in lab. All of this right here being our upper respiratory area, upper respiratory system. okay? Get to lower down here, all right? But there's something I want to point out about the upper respiratory system that is important. All right, for the most part, how do we take the air in? Is it, or is it? For the most part, you're breathing through your nose. There's a reason for that. What's the reason? To filter and to warm and to humidify. Why? Well, if we think about it, okay, right now, this air that's around us as we're here, is it 98.6 degrees? No. What's the air here? 98.6. We cannot have this air here that's going to be breathed in go in at the temperature that it is. It would be too much of a shock to the system, and the body would spend too much time trying to warm the blood around the lungs. Okay? So in the structure that we have in this nasal cavity, we got these cool little flaps right here. And they're really cool. Because when we breathe in, they're going to flap, okay? The air is going to come in, move across that flapping, and the air is going to be warmed. It's in contact with mucous membranes, so it's going to be moistened, okay, humidified, and then we can pass it to the lungs. Love those flaps. Those flaps are going to be our choanae. And they just every time we breathe through the nose. And that's their job. Make that air be amenable to the lungs. Now, as we continue to pass through this system, we'll hit the area that we know as the pharynx. The pharynx actually has three regions: the naso, the oro, the laryngo. Naso, like you would think, okay, with our nasal cavity. The oropharynx. This is going to be the area that goes with the digestive system. The laryngo, this one with the esophagus. Now, our larynx, kind of funny looking, okay, but the larynx is important, okay, because air does pass over it. It's got some really cool cartilage that's present, and it's going to also be a part that helps us with our voice production. As we move further down into the system, we're going to hit the trachea. The structure of the trachea is very interesting because the way that the trachea is going to be set up, this really long tube to the front, to the anterior side, we've got really strong cartilage shaped like a C, the letter C, that does this number. So that tells me that the posterior side of my trachea, those cartilage don't meet. Why?